Hi, Accelerated. I'm going to teach you guys how to go over parallel lines cut by a transversal. I'm going to start off really basic when there's no variables, but also go over when there are variables. But I'm considering those two different skills, okay? Just so you know. So our steps for parallel lines cut by a transversal. So write the corresponding measurements on one of the parallel lines. That sounds kind of weird at first. I'll show you what I mean. Then identify the angle relationship. Is it complementary, supplementary, or vertical? Write an equation for the relationship, solve for the variable, use the variable if necessary. Okay, so I'm going to use this. It says, if the measure of angle 2 is 115, find the other angles. But typically what this would look like more specifically is they would tell me, okay, it's 115. What's the measure of angle 7? So what I can do is move the 115 where it is now to its corresponding spot with the other piece. So from 2 to 6. That means that 6 is 115. Okay. Now that I know that, I can look at the relationship between 6 and 7. All right. So these are vertical. When they are vertical, I'm going to use X to show this, that means that they equal whatever the given amount is. In this case, 115. So I know all my verticals. If they had given me that but asked for 8, again, I'd move that 115 down. Look at the relationship between 6 and 8. Notice that they are on a line. So I'm going to use Y this time for 8. So Y plus the 115 should equal 180. So since I know that, subtract 115, subtract 115, I get that Y equals 65. So that means that angle 8, and I'm going to put it in a different color. With blue, that sounds fun, is 65. Oh, it matches, which means its vertical angle, 5, is also 65. And then 1 and 4, those are corresponding, so they are also 65. When you know one of these measures, you know all of them. Okay, they're a carbon copy from up here to down here. So that's how you just solve for any piece with parallel lines cut by a transversal. Okay, but they do get more complicated than that, and they have equations. Okay, so now I'm going to show you what happens when there's an equation. So I'm going to not use blue since it looked the same. I'm going to use purple. It says solve for the measure of angle TWV. So they want that angle. They want where 5x is. But I don't have any numbers here. So I really have to write the equation. So up top, it says write the corresponding measurements on one of the parallel lines. So I'm either going to move 4x down or put 5x up. So I'm going to move 5x up just so it'll be clearer to me. So here on this parallel line, it's in the top left. So it's going to be in the top left up here. I put it in its corresponding spot. Now that I know 5x and 4x are on the same line, and I'm going to show you that in a different color, they're on the same line. That means they're 180 degrees. I can write an equation for this. So 5x plus 4x, remember they add up to 180. We got this. When I have an equation like this, and I have variables on the same side, same variables, I can combine those. 5x plus 4x, that's why I boxed them both. Remember when we would box and circle. So 5x plus 4x, that's actually 9x. So I get that 9x equals, sorry if I something there, 9x equals 180. Then I can divide both sides by 9 in order to isolate my variable. And I get that x equals 9 can go into 18, 2 times there's a 0, 20. Okay, so x equals 20. That's great. Now I can use it because I need the angle TWV. So that's 5x, remember? But I know what x is, so I'm going to utilize that. 5x, that means 5 times 20, 100 degrees. The measure of angle TWV is 100 degrees. And guess what? That means I could figure out the rest of this. I'm going to erase what's there and do it. If this one, pardon, is 100, then this one is 100, then this measure is 100, then this one's 100, and the other ones have to add up to 180. So that means this angle is, oh, come on, 80, 80, 80, come on, and 80. The hardest part about these ones is when you do get those funky equations, but once you figure out x, use x within the expression they gave you, and you can solve for the rest. Like I didn't need to do 4 times 20, which still would have given me 80, but I could just use that information. Sorry. I have one more. This one says solve for the measure of angle BGE. This one right here. So there's actually nothing there right now. One sec. Sorry, I needed a glass of water. I didn't need to tell you that, but I already said 1 sec, so I thought I'd elaborate. I paused it and I'm back. Okay, so angle BGE. BGE, I didn't trace that correctly. But there's nothing there. I don't know what to do with it. I have 3x though, and I have 2x plus 50, so I have to utilize those. So I need to either move 2x plus 50 to the top line or move 3x to the bottom line. I want to move the corresponding figure to one of the parallel lines so I can see their relationship. So I'm going to move 2x plus 50. So since 2x plus 50 is in that top right corner, it's going to go in the, oh, that's BGE, top right corner here. So 2x plus 50. Oh, so once I solve for x, I just need to place it in there, substitute it in, and I know what BGE is. Okay, sidebar. So now I have them there. Now I need to decide on their relationship. Well, they aren't vertical. They're actually adjacent next to each other, and they're on a straight line, so they add up to 180. Even though these are funkier, I'm still just taking the two expressions and adding them. So 3x plus 2x plus 50. Don't forget the plus 50 part. Those add up to 180. Now I got to do some combining here, but I got this. So 3x, I would box it. 2x, I would box it. 50, I would circle. Remember, box your variables, circle your constants. I have two boxes on the same side. That means I have like terms I can combine. So 3x plus 2x, that's 5x. There are no constants on this side, so 50 plus 50 just comes down. There was nothing I did with the 180, so it just comes down. Oh, now I can solve this like a normal two-step equation. I have multiplication and division, or addition, my apologies. So I'm going to subtract 50 from both sides. That made 0. 5x equals 130. Divide by 5 because it's multiplication. And 130 divided by 5, I think it's 26, but let me double check. Yes, it is 26. Yay. So since x equals 26, now I'm going to use that in order to solve for angle BGE. Let's use blue. So 2x plus 50, that actually means I'm doing 2 times 26 plus 50. 2 times 26, that should be 52. (52) plus 50. I then get, what is that, 102? Yes. 102. that angle right there, that BGE, is 102 degrees. And then I could use that to figure out my vertical angles. So if this is 102, this one's 102. That means this one's 102, this one's 102. And those other missing parts are 78. And that's how you can solve parallel lines cut by a transversal. Bye, friends.